All right, so let's look at the last problem from this chapter. What would the Schwarzschild radius in light years be if our Milky Way galaxy of 100 billion stars collapsed into a black hole? Compare this to our distance from the center, about 13,000 light years from the center. All right, so what's not stated is it's roughly, well, so we're going to, I mean, I think there are more stars than that, but the mass of each star we'll assume is solar masses. Okay, so that's what we're going to say. The mass of the galaxy is 100 billion, um, which is 10 to the 11 solar. Here's the symbol for, this is the symbol for the mass of our sun. And the mass of our sun is 2 times 10 to the 30 kgs. Okay. And the Schwarzschild radius is given by 2gm by c squared, where c is the speed of light, and so c is 3 times 10 to the 8 meters per second. Alright, so this radius will come out in meters, and then we'll convert that to light years. Okay, so okay, let's put in the numbers. The Schwarzschild radius of the black hole created from all the stars in our galaxy, if you turned our Milky Way galaxy into a black hole, this would be the Schwarzschild radius. Okay, so 2g is 6.67 times 10 to the minus 11 Newton meter square kg square. Okay, and the mass is 10 to the power 11 times the solar mass, which is 2 times 10 to the 30 kg, divided by 3 into 10 to the 8 meters per second square. Okay, as always, let's take care of powers of 10 first. This 11 is killed by that. Oh, that's neat. That's good. So 10 to the 30, and 8 times 2 is 16. So what we have is 10 to the 14 in the top. Okay. And again, like I said, all the units should cancel, so that this should come out in meters. Okay. And the other factors are 2 times 6.67 times 2 divided by 3 square, which is 9. Okay. And this is clear. So 4 into 6.67 divided by 9 is 2.96 into 10 to the power 14 meters. And you can see that, okay, so we'll go back to one of the previous problems where we calculated light years, light year in meters, and I think a light year is okay, so here we go. Here is light year is 9.46 times 10 to the 15 meters. Okay. Okay, so, and this would be 9.4. Oops, no, let me do it in the next step. And so this is the Schwarzschild radius, And to get this radius in light years, it will be 2.96 into 10 to the 14 meters. And 1 light year is 9.46 into 10 to the 15 meters. Okay, so this is divided by 94. Okay, so 0.03 light years. Okay, and so 3% of a light year. And we are asked to compare this to the orbital radius of the sun, which is 13,000 light years. All right, so that just gives you a sense for it. And all right, I'll do one additional thing, but let me add a page. Okay, so the Schwarzschild radius is 0.031 light year, and 1 light year in a year, you have we'll calculate how many. 1 year, oops, 1 year has 365 days times 24 hours. We'll just keep it in days. Okay, so the Schwarzschild radius is 11.44 light days. Okay, so if you started at the center of this black hole, it would take you 11.44 days traveling at the speed of light to get to the Schwarzschild radius. That's what that number means. Of course, well, so roughly that's what that means. Of course, you can't do all of that, but in reality, you can't do all of that. But that's the radius of the black hole. If you collapse the Milky Way, and if you turn the Milky Way into a black hole, that would be 11.44 light days would be the radius, Schwarzschild radius. Okay, that ends that problem.